Okay, problem 27, we're going to separate this and look at, these are dealing with revenue because they're talking about what's coming in, and this is dealing with the cost because it says specifically cost. Now the cost function is pretty easy to set up, so let's do that first. It's simply saying that it costs us $6,000, a fixed cost, plus $32 per person. Now I'm going to let X represent the number of people on tour because that's what everything's asking about, how many people can go on this. The revenue is a little bit more complicated. We have to read this carefully. First of all, it's $200 per person if 50 people go. Okay, so the first 50 people, this is the minimum. We could think of that as 10,000, but this is going to be a changing value. It's kind of like saying once we get 51 people, then rather than the first people paying $200, everybody, all 51 of those people are going to be paying $198. And if it jumps up to 52, then we subtract, it reduces by $2 per ticket, so each person will be paying $196. So this is going to go up to 80 people. Okay, so if we start with our base rate here, thinking about putting this together, we'll start with saying, okay, that would be like 200x. Okay, I'm going to kind of write this off the side. Or maybe we could just say here 200x, but we're looking at a range of 50 people with a maximum of 80 people. Okay, so we have a minimum number, so we're not really going to use this. This would only be good if 50 people went. Our function is going to look a little different. Let's look at what we need to do to that. They're saying that we're going to decrease. It'll be reduced by $2 per person, and that's going to, again, include the first 50 people. So let's think about the discount that we're getting. How much money are we discounting? We're not just discounting 2 people, it's actually 198. So our actual discount is going to be, it's going to be $2 times the number of people over 50. So the number of people are over 50, it's going to have X people minus the 50 people we aren't counting. So this discount doesn't kick in until we have 51 people. If I use 50, I would get 0 here. There is no discount. If I use less than that, if I use 49, it wouldn't make sense because it's outside of our domain. And so as I go up, if I go up to the 52nd person, that would give me 2 times 2, give us a discount of $4 and so on. And so we're putting that discount in here. That's going to be minus 2 times x minus 50. So then our revenue could be simplified to negative 2x squared plus 300x. So those are our basic functions for cost and revenue. If we want to solve this then, following the rule that they gave us in this section, we want to look at c prime of x, which would give us 32. And we could look at revenue, the marginal revenue, which is going to give us negative 4x plus 300. Setting those equal to each other, we can solve that and get 67 people. There's only one solution there. We want to check and make sure that that's a maximum. There's a couple ways we do that. The book actually does it this way. Rather than using their shortcut, they actually found it easier to look at the profit function. Or even p prime here, since we've got c prime and r prime, our profit would be r prime, like the derivative of profit, r prime minus c prime. If we want to make sure that there's a minimum, then we can look at the second derivative and use the second derivative test. So looking at our second derivative, we could take the derivative of r prime, which is negative 4, minus the derivative of c prime, which is 0. Notice that this is always concave down, which is telling us this point would have to be a maximum. So we're talking about 67 people is the maximum number, is how we would maximize our profit.